Hey guys, we're going to do a video here on something called surface area of prisms. And there's lots of different types of prisms, so I'm really going to focus on two types today. And really the most important thing you need to know is a prism is a three-dimensional shape. We have names for 3D shapes, and we're going to focus on rectangular prisms today. So imagine we have kind of like a box. So I'm going to draw my best three-dimensional box. Now, I don't know what your 3D drawing skills are like, but mine are so-so. So there's my 3D box. There's my box. Imagine you're holding this box in your hand. If you were holding the box in your hand, I don't know how big it is. Maybe it's huge and you're holding it like this, or maybe it's small and you're holding it in the palm of your hand. But on the outside, we have what's called a surface. The surface is the outside of the box. So on the outside, we have all these different surfaces. And what we want to do is know what the total area of all that surface is. Imagine it was your job to paint the box, and you were going to paint all the different sides of the box. Well, you would need to know how much surface area you need to paint. So the way we do this is we picture this object as having different faces. Each side is a face. I use the word side, and then I realized I really shouldn't say the word side. I should say the word face. So to give you an example, I am holding a box in my hand right now. Hopefully you can see it on that small screen. It's really just like a dice. We used it in a game, in a math game in our classroom a few weeks ago. But if you look at this rectangular prism, it's a perfect box, and you think about how many sides or how many faces does it have, the face would be where you put your dice number. So think about when you roll a dice. How many sides does a dice have? 6. So there are 6 faces on this object. And our job is to find the area of every single face. So imagine that you could take each of these faces and shade them in with like a colored pencil. Let's start with this side. I'm going to shade that face in with kind of a blue-purple colored pencil here. Now, if I need to find the area of that one face, I think of it as a square because it looks like a perfect square. It's going to have a length and it's going to have a width. So I would need some numbers. And if I told you that this was a perfect box, then you would know that the length and width would have to be the same thing. So let's imagine that it's 5 centimeters. That means the measurement on each of the edges is 5 centimeters. So it's a 5 by 5 square. And a 5 by 5 square has an area of 25 units, square units. That's one face on this whole entire prism. So now I pick a different colored pencil and I say, okay, well now I did that face. So now I'm going to do this face in the front. Here's the front. The front I'm coloring in orange. I'm going to write that down maybe over here on this side. So the front looks like this. And the front has the same measurements. It's a 5 by 5. So 5 by 5 has an area of 25. Same thing. Now to help myself kind of keep coordinated on this, I'm going to color this in orange. So I remember that one was the front matching this face. I'm going to color this one in with my purple-blue color so that I remember that these two match. And if you think about it, what I've done with my box is now I've looked at the front and the side, but I still need to deal with the top. So the top, I'm going to pick a third color. Let's do like a light blue. Here's the top. And what shape is the top in? Well, the top is still like, here's the box. If I turn it, the top's just a square. So we're still dealing with squares. So now I'm going to do the top, which is going to look like a square. We know that it's going to be a 5 by 5, just like all the other sides. So it has an area of 25. And I'm going to shade it in blue to match the top. Now for showing my work and trying to be organized here, here's the front, here's the top. I'm going to call this one the side. But think about our dice. Remember it has 6 faces or 6 sides. So what we've done is we've done the top, we've done the front, and we've done the side. But we're going to double that. There's a top that matches the bottom. The top and bottom match. There's a front that matches the back. There's a left side and a right side that match each other. So what I'm going to add to my notes is this is the front and the back of the dice. This is the top and the bottom of the dice. This side is the left and the right side of the dice. So right? Left/right. Which means if my job is to find the total area of the entire dice, of the entire box, then I'm going to call that total surface area. Total surface area. I'm going to be adding up the area of the front, the back, the left, the right, and the top and the bottom. I'm going to add up all of those areas. So the front is 25 plus the back is 25. The left and the right were both 25. Left plus right. The top and the bottom were both 25. So I'm going to add up all of these. Here, I'll squeeze one over here. There's all my different sides of my prism. Now, another way I could have done that is I could have said there's two 25s for the top and the bottom, plus two 25s for the left and the right, plus two 25s for the front and back. That's another way I could have shown my work. But think about that. 25 and 25 make 50, and this would be 50, and this would be 50. And if my job is to add all of this up, 50 plus 50 plus 50 is 150. So my answer is the whole surface area of this entire box is 150. And if it's area, I'm going to write centimeters squared. That's all measured in square centimeters. So over here, I'm going to write SA for surface area, put a box around that, and that is my final answer. So surface area is looking at the area of all the different faces of the object. Now boxes are the easiest because the box has a square side for every top, bottom, left, right, front, and back. But they can be more complicated. Prisms don't necessarily have to be made of a perfect square. So let me show you some different examples that are a little bit more complicated. So here's one. I decided not to draw it myself, but just to print it out. Sometimes it's easier to do that. Here's a prism. It does look like a box, but it's not a perfect box made of squares. It's called a rectangular prism because it's made of rectangles. So I'm going to write next to here, this is a rectangular prism. Rectangular prism. It's a 3D object made completely of rectangles. And so our job is to find the surface area. So we're going to break it down into all of its parts. And I'm going to use a colored pencil again to do that because I find that kind of to be an easy strategy for me at least. So why don't we start with the front? Here's the front, I'm going to say. I guess I'm kind of choosing what I deem to be the front. You might think the front is this bigger side over here, but I'm going to say that this one right here is the front. Now, of course, if you need to draw this in your notes, you can pause the video and take a couple minutes here just to draw this out. That way you can kind of color and follow along with me. So I'm going to write over here the front. Looks kind of like a long rectangle. And we know that the front is going to match the back. So this is the front and the back when you really think about it. And I chose to make that my purplish color here, so I'm going to color that in. Now if you look carefully at our 3D prism, our picture over here says that it measures 5 by 12 kilometers. So it's a 5 kilometer by 12 kilometer area, or dimensions, excuse me. To find the area, we're going to actually have to multiply 5 times 12 to figure that out. So we'll have to do a little bit of multiplication here. So 5 times 12, it doesn't bother me if you need to use a calculator, but you should know it's 60. So 60. That is our front and our back. Now let's do, how about top and bottom? So I'm going to make the top orange. I'm going to change my color. Here's the top. It is this piece right here, all in orange. The top, which I'm going to label over here, top and bottom, are going to match each other. And for the top and the bottom, let's get our dimensions on here. So it looks like it measures 5 by 11. So I'm going to draw a rectangle that is 5 by 11. So I'm going to have to do 5 times 11, which I know is 55. So the area of the top and the bottom is 55. And since that was my orange, I'll color that in orange so I don't forget. And then I'm almost done. I've got top, bottom, I've got front, back. I need the side to side. I need the left and the right, which I'm going to do in blue. And that is this big side right here. That face, which I'm making blue. think I'm going to highlight it even. Like, look, it's this big face. So it's a big rectangle. I'm going to make it look kind of like this over here. And this is the left and right side. Left and right. Now, if you look at our picture, the dimensions look like it goes 11 long. So it's definitely 11 kilometers long. But height-wise, or this dimension right here, remember this was 12 over here, so it's got to be 12. So it's an 11 by 12 rectangle. So we got to do 11 times 12 to figure out what that is. And let's do some quick calculations here to see. So 11 times 12 is 132. So it has an area of 132 on the left and the right side. And what I'm going to do is I'm going to color that in blue to match my picture. And then I'm almost done. I've done all my different faces. Now I just got to add this up for total surface area. So I'm going to write total surface area, total SA for surface area. I'm going to add up the front and the back. Now the front and the back was 60. So there's 2 of the 60s. Plus I'm going to add up the top and the bottom. So there were 2 of the 55s. Plus I'm going to add up the left and the right here. And I'll scoot over so you can see my work a little bit better. So I have to add up 2 of the 132s. 132. And so my total surface area is going to equal 2 times 60, okay, I know that's 120, plus 2 times 55, which I know that's 110, plus 2 times 132, so that'd be 264. And then we have to add up those values to get our final answer. So total surface area equals, we're almost there, we almost have our final answer here. So we've got to add up 120 plus 110 plus the 264. And that gives us a grand total of 494. So our total surface area is 494. And the units are square kilometers. So you can write 494, you can write square kilometers. Or if you don't like to write it that way, you could write 494 kilometers squared. Both of those answers count as being correctly labeled. But this is our final answer. So take a quick moment before this video ends to notice how organized the work is. I think there's kind of a process to this. You really want to make sure that you're looking at your 3D object and sketching it out nicely. Now, I know drawing the actual 3D object can be kind of a challenge, but you can definitely sketch out the sides, the faces, without too much of a challenge. And then make sure you're labeling everything. Notice how well I'm labeling and color coding, and I'm showing each step of the way. I'm trying to be detailed. Basically, I want to make it so that anyone can look at my paper. They don't have to know who I am. They can just look at my paper and know, hey, she knows what she's doing. She knows how to find surface area of a rectangular prism. So that's kind of what I'm hoping your work looks like also. Okay, thanks guys. There's going to be more videos on this.